we're going to go ahead and we know that the cosine function, cosine of 1 over x squared, the cosine is always in between 1 and -1. And that's just because of how the cosine is defined. So we're going to go ahead and multiply this inequality by x squared. So we're going to have negative x squared is less than or equal to x squared cosine of 1 over x squared, which is less than or equal to positive x squared. So now we have constrained our function x squared times cosine of 1 over x squared between two other functions. From below, negative x squared, and from above, positive x squared. And now we could go ahead and just evaluate the limit. The limit as x approaches 0 of negative x squared is less than or equal to the limit as x approaches 0 of x squared cosine 1 over x squared less than or equal to limit as x approaches 0 of x squared. And from here, we know what this limit is, and we know what this limit is. Both of these are 0, so 0. I'm going to go ahead and rewrite this part here. And this part 0 too. So by the squeeze theorem, we had to use the squeeze theorem. By the squeezy theorem, the limit as x approaches 0 of x squared cosine of 1 over x squared equals 0. That cosine, the cosine function, regardless of what's inside the argument, it's always going to be between -1 and 1. Using that inequality, we multiply everything by x squared because that's what the original function has. And this right here is telling us, let me use a different color here. This right here is telling me that the function inside lives in between these two functions. It lives in between positive x squared and negative x squared. In fact, I'm willing to guess that it looks something like this. Hang on, let me draw it in red. Something like this. In red. In fact, let me see if I could find a graph. So this is what this function looks like. That's the function x squared cosine of 1 over x squared. Pretty neat, huh? And you could see where the x squared function and negative x squared function is traced out. Next problem.